We're going to look at a few examples here dealing with those inequalities that we're going to see in triangles. In this first one, I want to find all the measures, or all the angles that have a measure less than the measure of angle 14. To just identify, we have angle 14 up here. I want to find all the angles that basically are smaller than this one, or that I know that have to be smaller. Now, there's going to be some that definitely look smaller, but remember, we can't go by what it looks like. We got to go by given information, and specifically in this one, the exterior angle inequality theorem. Now, what I'm going to do is I'm going to look at it like this. I'm look at angle 14 as an exterior angle, or of a triangle, and I've highlighted that triangle right now. Well, if I do that, I'm going to look for remote interior angles of angle 14 because I know those are going to have to be smaller or less in measure than the measure of the exterior angle. Angle 11 is an exterior angle of angle 14, or excuse me, angle 11 is a remote interior angle. Therefore, I know that it has to be smaller than the measure of angle 14. Angle 4 is also a remote interior angle of exterior angle 14. Therefore, I know that one has to be smaller. And I've so far found two angles that I know have to be smaller in measure than the measure of angle 14. I could also make my triangle like this. Well, what that's going to do is that's going to change exterior angles for me. Now I know angle 2 is a remote interior angle of my exterior angle 14. It has to be smaller. I also look at this entire angle is a remote interior angle of angle 14. Therefore, it has to be smaller. Well, if I break it up into pieces, which it has been with angle 3 and angle 4, well, then this one's going to also have to be smaller in measure than the measure of angle 14. So I found myself a couple other ones. To continue on, I'm going to get rid of that, highlight. Now I can go another way, and I'm going to go like this now. I'm going to look at angle 11 as being an exterior angle of a triangle. Of the triangle that I've highlighted. Well, then, angle 7 is a remote interior angle to the exterior angle, angle 11, and so is angle 6 a remote interior angle to angle 11. Therefore, I know that the measure of angle 6 is smaller than the measure of angle 11. Well, if the measure of angle 11 was smaller than the measure of angle 14, obviously then the measure of angle 6 is smaller than the measure of angle 14. Similar effect, we'll get the measure of angle 7 to be smaller than the measure of angle 14. Now there's one more that we have to look at. And some of you have probably already identified it already. You're looking at it and saying, well, if the measure of angle 11 is smaller, then the measure of angle 9 is also going to have to be smaller because angle 9 and angle 11 are congruent. Then there would be all the angles that I know are going to be smaller in measure than the measure of angle 14. Could there be others? Yes, there could be, but those are the ones that I will be guaranteed to be smaller using the exterior angle inequality theorem. Now on the next one, I'm kind of going to go the other way. Now I'm going to look at angle 5. Now this time I want to find all the angles that are larger in measure, have a greater measure than the measure of angle 5. So what I want to do in this time, I want to look at that as a remote interior angle and see if I can find an exterior angle to a triangle that it's in. And the first one I'm going to look at would be right here. Angle 5 is an angle in that triangle. Angle 10 would be would be an exterior angle. Therefore, I know angle 10 is going to be larger in measure than the measure of angle 5. I'm going to start right away with this vertical angle. Angle 12 will also have to be larger in measure than the measure of angle 5. Now I can go and kind of highlight another triangle. Now this time I'm going to look at angle 10 as being the remote interior angle. And I'm going to look at this triangle. Well, if that's the case, angle 16 is the exterior angle. The exterior angle is always going to be larger in measure than the measure of the remote interior angle. So I know the measure of angle 16 is going to be larger than the measure of angle 10, which was already larger than the measure of angle 5. Therefore, the measure of angle 16 will be larger than the measure of angle 5. I can go the other way with this, using angle 12 now as the remote interior angle. Angle 15 would be the exterior angle. Therefore, exterior angle is always larger than the remote interior. So the measure of angle 15 is larger than the measure of angle 12, which is larger than the measure of angle 5. Get rid of that. And then I'm also going to look at one more angle. Go back to my angle 5. I'll look at it like this. Angle 17 would be an exterior angle of the triangle that angle 5 is in. Therefore, this exterior angle is going to be larger in measure than this remote interior angle. And there would be all of the angles that I know have to be larger in measure than the measure of angle 14. And again, yes, there are going to be some that actually look larger in measure, but we can't prove it using any theorem. Now on this one, I want to list all the sides of the triangle in order from the smallest side all the way up to the biggest side. Now, one thing that we need to realize here that I didn't write, but this triangle may or may not be drawn to scale, and I would say obviously not drawn to scale. That angle appears to be acute, but I've stated that it's 100 degrees. So this is not drawn to scale. Now we have to think about that other theorem that I was looking at, where the biggest angle is opposite the biggest side and the smallest angle is opposite the smallest side. So what I'm going to do, if I want to go from smallest to largest, I want to find my smallest angle. So I'm just going to I'm going to number these. Here's my smallest one, here's my medium one, and here's my biggest one. Now if I go opposite, that's going to have to be my smallest side, my medium side, and my largest side. So if I'm going to list these in order, I'm going to say the length of segment LH is going to be less than the length of segment JH, which is less than the length of segment LJ. And there I have an inequality listing my sides in order from smallest length to largest length. This one, similar concept, but now I want to list the angles in order from smallest to largest again. And this time I did write in there that the triangle is not drawn to scale. But I'm going to do that same thing I did last time. Well, here's the smallest side, the medium side, and the biggest side. Always go opposite. So this is going to have to be the smallest angle. Here would be the medium angle, and here is the biggest angle. Now this time when I write my inequality, I can say that the measure of angle J I know is less than the measure of angle C, which is less than the measure of angle R. And there are a few examples dealing with the inequalities in a triangle. I hope this will help you, but remember, anytime you have any questions, let me know.